hopefully. Yay, we're live now. Awesome. Cool. And then let me add that in the chat. And then select. Yep, good. I think in like 10 minutes I'll see if like TikTok will let us go live, because I think our 3-day ban ends in like a minute or two, but I'll check in a bit.
Yeah, that's my fault for saying black.
Emotional, damn it!
I want to see how the auto bleep works. They have an auto bleep feature that they said you can turn on to like automatically censor stuff. I'm like, cool. If you want to auto censor my stuff, I don't care. I hate having to walk on eggshells thinking about like, you know, I can't like call myself dumb or something, or they say it's like self-harm. I'm like, man, chill. It was a good video you posted, Sensation, about the whole censorship thing. I like that one. That was a good one.
It's accurate though.
Oh, 100% is. No, it very much is. Yeah, they're changing like, the language.
The other thing that bugs me as well is it's young people. Every generation has its own slang, but
yeah,
the slang that most young people employ now is not their own. It's
corporate.
It's not only is it somebody else's, but it's specific to a particular place in America.
What do you mean by that? Are you talking about like when they say like grape and they say like restarted and like all this other dumb shit?
No, like Ima or Ima, because they don't even write it. They don't even write
There's
that.
yeah. I know what he's talking about.
Wait, what's he talking about? Sorry, educate me. What's up?
Like,
It's specifically African American slang.
yeah, I was waiting for someone else to say it. I just didn't
you can
wanna
say it's a black
blatantly
thing. I don't
say it
care.
like that.
No, you can say it. It's fine. It's hood.
Yeah, no,
Not,
it's very.
but not
It's like-
African American slang in the general case. I'm saying it's specific to a region.
What region? Like New
California.
Orleans?
No, not California. What the fuck am I saying? Where the fuck does Eminem live? Where's Detroit?
Oh,
Detroit.
yeah, Detroit.
Oh, Detroit.
Detroit.
I got some good friends in
Chicago.
Okay, so it's like gang slang.
Like, yeah, pretty much.
Okay. Yeah.
I heard a lot of this. I heard a lot of this slang growing up.
Yeah,
in rap
they've
music.
always had like gang slang and stuff, dude. Like you can barely understand what people are saying. But you're saying like it's even more prevalent now, or like what?
No,
Yeah.
I'm saying that's everyone's
that's what
slang
I'm saying.
is that specific slang. And
I mean,
it's
I'll
not
say stuff
their
like
own.
I'll say stuff like finna, like, you know, finna do this, or like tryna, Tryna. My one friend used to say it all the time. Tryna's kind of cool. What's up, York? Yeah, language is cool, but I also appreciate that we should like try to, you know, have some standard of English, so we can not, you know, degrade too far into degenerate speak. But also, I get it. Like, I'm not gonna shame people necessarily because then we ostracize those people, and then like they don't want to ever like associate with the stuff we do. So I'm not gonna. I don't know what I'm saying. Let's do
See, I
that.
take a very different perspective because I see these people struggling already, and they don't need the additional struggle.
I see. Yeah. Well, sometimes you got to speak their language so that they want to get help. You know, instead of
Right, and invariably they will have to unlearn all that shit. So
correct. Yeah. Okay, let's go. Spin the wheel. Whose question are we going to answer today? Breskel says, "I'm sorry." So let's see how sorry I'm going to be at the beginning.
Let's go gambling!
How sorry am I about to be? Oh, I got 8.
Apparently not. You got it.
Probably not too sorry yet. What's up,
Not yet.
Jordan?
Not yet.
Oh, beautiful. PH? Yeah, dude. Hell yeah. I love this stuff. Mog, their slang Rizzler. Finna stink a dumb HOA skin. HOA skin. No idea what it means, but it sounds young. Dude, what are you saying, Jorgen? What?
I mean, it just seems like something a lot of the youth would say.
The youth. I'm just gonna call him the
So in
youth.
fairness, Sensation was kind of wrong. There's a lot of youth slang that's popped up that's
Okay.
just like mental
That sounds like hood
deficiency
scheme.
from TikTok. No, it's
Yeah,
not even like
brain rot.
hood. They're just like every brain rot thing that's like popped up in the past like 4 years has been like combined into like
Into a hot
and,
dog,
like-
dude. We've taken
Yeah,
all the
it's-
bits and all the trash, all the eyeballs and all the whatever, and we've grinded it up, and we've made hot dogs. We're back.
What was crazy is they're like fluent in it. Is what concerns me.
Oh.
Like these kids like can't do anything, but like
But they can speak
they'll
Mog.
put the effort in to learn like brain rot speak or
Oh,
whatever,
okay.
whatever the hell they be saying. Like they're fluent in that shit.
It's too funny. Back in the day, they tried to like teach ebonics.
Oh no.
It's like a thing in the 90s, I think. Which I think is kind of what we're talking about, right? We're talking about like degenerate hood speak stuff. But yeah, and then they realized, wait, this is actually not actually a language. Like we don't actually need to teach this. This is also like super racist to like do this.
I think they even redacted the term ebonics in the end.
Yeah, ebonics. Yeah, I don't think people know about that. Okay.
No, do you know what bugs me out? It's like, remember, we were around during the Nokia 3310 era.
Sorry, the what? Sorry, what did you say?
We were around the Nokia 3310 era.
The Nokia 3310 year? Sorry, what? Maybe I'm not
Oh,
speaking
right.
English.
So text messages used to cost 10 pence per text message, and they used to have a character limitation.
Correct.
So you could only sort of send one block of text. Anyway, the point is that this text slang evolved, and now
sure,
these
like
people
LOL.
do it, and it's like no, like ooh ah.
Or like instead of saying whatever, you say like WVR, right? Or instead of saying
Yeah,
like with, we would do this, right? This was with contractions or sorts, yeah.
Yeah, but then you see people doing it now, and it's like you don't need to because you have
Yeah, because we don't have financial
total
struggle.
data control.
Yeah, correct. How did y'all get NASA badge? Wait, what's the NASA badge? I have a NASA badge? Where's my NASA badge? What are you guys talking about? Oh, wait, wait, what? What's up, Pete said? Raven, what are you talking about NASA badge? I'm curious. I forgot what titration is. Honestly, I couldn't handle chem, but I thought it was related to acids. It is related to acids and bases, yeah. So what a titration is usually you have a known amount of concentration of some sort of acid or base, and this is called the titrant. And then you end up pouring it into a liquid of an unknown acidity or an unknown concentration. And once the color of the mixture changes, you know it's at what's called like either the equivalence point or something, and then you can use that to figure out the concentration of your unknown liquid stuff. Oh, okay. Fembox says, watch the NASA Twitch channel thing. Oh, cool.
Yeah.
Oh, sorry. You're talking about like in the chat, people have the NASA badge. Oh, that's very cool. What is that software called? Kratos says, what software? What software are you talking about? This came from like a student submitted this question. I don't know what the software is. Or are you asking about like my whiteboard? Or you could be asking about the Q system. Like, there's a lot of things you could be asking about. The whiteboard. Okay, the whiteboard is Group World. It's called Group World. Yeah, it's these people. GroupWorld.net. I think I pay them like $20 a month, which I've been, or $25 a month. I guess I pay them, but it just works. Yeah, and I'm super used to it, and I just write it off. It's a business expense. Okay, so nitrous acid. I think nitrous acid is nitrate with hydrogen, which I believe maybe that's H2NO3. Could be H2NO3. I forget if NO3 is a 1- or 2-. That's like nitrous acid. Oh, HNO2. Oh, okay. So I was even more wrong.
Emotional, damn it!
Okay, it's HNO2. Pharmacy work. Lewd acid and base. Yeah, I mean, I think so. We have to see like whether this is a strong This is definitely a strong base. This is 100% a strong base.
No.
And I assume they're saying after 15 milliliters of the potassium hydroxide's added, The question is whether this is going to form a buffer. I want to say nitrous acid is weak. Yeah, nitrous acid is weak. Okay. Okay, so this can form... Yes, nitric. Sorry, yeah, that's what I was thinking. Yeah. Yeah, is nitric HNO3 then? Because I thought nitrate was NO3. Like phosphate's PO4. What's up, Fu? But anyways, if you have a strong base with a weak acid, this can form a buffer. And this is before the equivalence point, right? Because, well, actually, we don't really know. I got to do some calculations. All right, let's just... All right. In this case, I'm pretty sure we have to do an ICE table. Let's do it. ICE. Not like the government organization that steals people. Okay. So, initial is 0.215 molar of nitrous acid. Okay, so this is going to be 0.215. And then we have 0.250 of the potassium hydroxide. And then, let's see. I think we do love ice tables, yeah. So this is going to be KNO2. And then I got to remember what happens. I think you're still going to have some of the OH left. Or... Let's see. Let's see. Let's just see what happens. Also, okay, this is why I don't think we're using an ice table, because I wasn't given a KW or a KA. Sorry, I wasn't given a KA or a KB. I need a dissociation constant, if I could use that. Okay. I think this is what happens. This is going to be this is going to be 0.215 molar times 20 mils. So that's 0.02. And then this strong base is going to be 0.25 molar times 0.015. And what I want to see is like, is there like enough base to neutralize all this weak acid so that there's going to be some strong base left over? Or do I not have enough? And then we'll calculate some equilibrium stuff. But yeah, well, you need KB, right? Your username is Fork. Imagine being that guy that was sent to that place in El Salvador and got sent back. Holy, what a break that guy caught in the cruel world. Yeah. The guy that went to prison and then he wasn't in prison. Because all the media decided to use him as like a poster child. They called him like the man from Maryland or something. I think was his. Yeah, that's what they started calling him. Yeah, which utensil do you want to be? You're gonna guess everyone wants to say like a spoon or something. All right, 0.25 times 0.015. That's gonna get us 0.00375. So moles of that, and then we're gonna do 0.215 times 0.02. That gets me 0.0043. Yeah, I think we need a KA actually, right? A peeler? A peeler would be fun. Because look, okay. 0.25 times 0.015. Yeah, and then we have 0.02 times 0.215. So there's not enough base to eliminate the acid. Completely. So, okay. This is going to neutralize into H2O plus KNO2, right? Is this balanced? Let's see if this is balanced. I think it is, right? 3 oxygens, 3 oxygens, 2 hydrogens, 2 hydrogens, nitrogen, nitrogen. Okay, so it's balanced. So these will eliminate. Yes, I do remember the log pH thing, but I'm going to show you what we have to do. Yeah, so wait, these will kill each other off, right? So that means that 0.0043 minus 0.00375 is the amount of HNO2 that's going to be left. Okay, so there you go. So then you have 5 times 10 to the minus 4 moles. So man, this is the HNO2. This is the KOH. We're going to have this many moles of HNO2 left. All right. Now, this is a very weak amount of HNO2. It's a weak acid. So I think this like forms a buffer just in water by itself, right? So I think now what you have is you have HNO2 plus H2O is going to form H3O plus, right? Plus NO2 minus. Because this is an acid. Yeah. Yeah, right, gas? Yeah, okay. Yeah, and now this is so now this is a buffer. This is a buffer. Because you have weak acid. And even more so, you don't really have much of it, so weak acid. Plus water. And let me think here. Okay. Also, I need moles isn't what we use here. We always use concentrations. So let me get a new concentration. We're going to do 5 times 10 to the minus 4 moles. And then we're going to divide it by the volume of liquid, which is 35 mils. So that's going to be 0.02 plus 0.015. Okay, so let's divide that by 0.035. And so that's going to give me 0.0157 molar. Molar. Okay. All right, great. So now we have weak acid. So now I think we can do an ice table. Yeah. This right here was actually technically an ICF table, right? Because this is. Here, I really should do that. Let me show you how that works. Goes down. Okay. This is really ICF, is what it is. Initial, change, final, right? So then this is going to be minus 0.00375, minus 0.00375. This is going to be 0. And then this is going to end up being, whatever our number was 5 times 10 to the minus 4. Yucky, old arithmetic, more painful integrals. Right, but this is moles. Okay. And then we wanted to convert that into... Good, that's how we do the concentration. Just want to get this all arranged so it looks nice. Okay, great. Okay. So yeah. ICF is when you have, again, strong acid or strong base neutralizing another either acid or base. You just have them like kind of eliminate each other. And then if you're left with just weak acids or just weak bases. So this is ICF. Yeah, so this right here is ICF. So this is final blanked. And this is what happens when... This is not an equilibrium reaction, by the way, right? This is a strong base with a weak acid. Those two are going to like straight up try to eliminate each other Well, the base is gonna like try to munch as much of the acid as it can. In this case, we didn't have enough strong base to eat all of the weak acid, so there's now going to be some weak acid left over, and then that goes into equilibrium with water as a buffer, and that's where we calculate pH this way. Okay. Get some sleep, Raven. Bratskill says chemistry is propaganda. Where are the integrals? Where are my derivatives? Real science is calculus and fractions and letters that I mean, okay. Chemistry definitely does have derivatives. If you do like rate,
I still don't respect chemistry as a science.
Oh,
okay?
dude, really?
You know,
really? I love chem.
Well, no, I don't like it because it feels very like cookie cuttery.
Oh,
I really
okay.
like to understand like what I'm doing rather than just spend 4 years learning like 100,000 different techniques and exactly what specific edge case to use it for.
I see. There's not like a general
Which
framework
is
that
like-
you're using things.
Yeah,
with.
like I can go into math and physics and generally like understand a lot of it, you know, like physics. I'm like, okay, it's basically all like energy or work, right? And nothing else, or like, you know, math, I can figure it out. But like you go into like chemistry and it's just like, yeah, this is how this reaction goes unless there's this specific thing happening, and then it's this other case and you're gonna notice it, and it's like,
yeah,
you know, it's kind of like calling you know, banquet the TV dinner brand, calling them a restaurant. It's like they're not really a restaurant. They don't really like know how to make food. They just mass produce a bunch of microwave food. Is how I feel about chemistry.
Okay, interesting. He's referring to them as banquet meals. Yeah, for the readers that don't know what a banquet meal is, let me show them. Like a TV dinner. Yeah, this is a banquet meal. They make it look so tasty on the photos, dude. Right?
Hey, they have the nostalgia flavor to them. That's what I would eat, like, especially like in middle school. I would get like, because I mean, for a middle schooler, these were fire.
Yeah, this is okay, but I mean, but then you actually look at it and you're like, oh dear. And yes, they used to be $1, dude. This used to be so cheap.
Yeah, they used to be. They were cheap, and like the spaghetti and meatballs was what I would usually have, and those were gas.
Yeah, I guess now they're like $1.87. Okay, not bad. This was always the luxury one, dude. Kid cuisine, dude. I always wanted kid cuisine, but my parents were like never like rich enough to afford it. But kid cuisine, dude.
Well, I remember those. I would get
This was like rich people shit
when
right
I
here,
was. But yeah, anytime we had babysitters over, my parents would get
Level
one of those.
up, dude. Wow, wait, they actually put how much proteins
Not
in
that
these things
fancy
now?
shit, man.
Look at this, dude. Look, they now say like how much protein's in it.
Yeah, that's just way too fancy for me.
This is way too fancy. Yeah, dude. I remember like the brownie and stuff. Oh my god, this is nostalgia. Anyways, okay. Here's a question. I think when this reaction happens, though, I think I do have to account for like this being produced, because in my equilibrium, you always have like an acid, and in this case, this is like the conjugate base. And I do believe we have NO2 now in our solution from like this elimination that happened at the beginning. We don't really care about the amount of water. Water never really works. Or water, we don't really care about water. But this one, I think we do. I think so. This is gonna be like plus 0.00375. And so that's gonna be 0.00375 moles, I think. And then we may be able to just do Henderson-Hasselbalch at this point. I'll have to see. But then if I want to convert this into a concentration, I'm going to have to do 0.00375 divided by 0.035. Go away, kid cuisine. Okay. So if I do 0.00375 divided by 0.035, That's going to give me 0.107 molar. Okay. What are we studying? We're doing chemistry right now. Someone's asking a chemistry question, and so we're helping them out. Okay. You're like 99% sure fork? Okay, well, let's see. Let's see what you get. Okay, so this is going to be 0.107. I could be doing this completely wrong. I'm pretty sure I have no reference right now. I'm just trying to figure this out. Okay. Now, from here, again, this change is going to be minus x. This is going to then be plus x. This is going to be plus x. And then we're going to have an equilibrium amount. So here, you're going to have 0.0157 minus x. This is going to be x. And then this is going to be 0.107 plus x. How do you send questions? Good question. So there's a website. So if you go to actualofficehours.com, which I think is posted everywhere, but I'll also put it in the chat here for you. Click on that website. And then this is where you can type your username in. You can drop a screenshot in and then just hit upload. And it'll get added to the queue. And once it's in the queue, we roll like a little spinner thing to see what happens, see who it gets. Why did God make me retarded? You guys. Oh wait, ooh, my TikTok works, but my green screen's not working. What's up, Sensation? I haven't started TikTok yet, so you're okay.
He did it to himself.
He did it to himself. Did he? Did he though? Sometimes nature versus nurture is a thing, though, right?
Well, yeah, but then at the end of the day, there's a thing called a library.
There's a thing called a library. Yeah.
Yeah, I mean, the first red flag is using a T. Using a T in retarded.
That is true. That is true. Yeah, that is true. Oh, chroma key. Okay, there we go.
Smooko, okay. That's just how sensation is.
Okay, we're gonna start on TikTok. So let's see if they'll let me go live, and then then we'll try saying like some things. But we should start with like light things, you know, like some light cursing. Let me see if it lets us.
Black.
Don't do it, Sensation, please.
Oh,
I was gonna say who's saying the big one.
Instantly banned, just like right away. Okay, apparently we're live. Okay, cool. All right, let's see.
Light swearing. So, fannies, bombs, willies. I don't know.
Oh no, dude. Oh no. Okay. Okay, so once we're here, I think what we need to then do is I need a Ka for nitrous acid, right? Let's do it. So Ka for nitrous acid.
I remember, kids, don't snort nitrous acid.
Nice. Yeah, don't do that. Nitrous HNO2 is 4 times 10 to the minus 4. Wait, what's like the general one? Oh, commonly 4.5 times 10 to the minus 4. So Ka equals 4.5 times 10 to the minus 4. And that's going to be equal to the products over the reactants. I think. Yeah. So this is x times 0.107 plus x. And this is over 0.0157 minus x. And then I think you solve for x here is what you do.
Yeah. All I'm saying is in physics, you wouldn't have to look up a value. It would just be like E
but if you're,
or C.
But if you're in engineering,
F.
you would. Engineering, you'd 100% have to look stuff up. Like, this is just the real world, right?
But
I
engineers don't count.
Oh, no.
They ride on the backs of physics.
Yeah.
They
ride on the coattails.
Discover.
The coattails.
Yeah, they let a physicist figure it out first, and then they use that to make money.
I think so. Now I think what happens here. I think X is small, so I think I'm allowed to ignore it. I think I'm usually allowed to just like get rid of this. Let's just do it. Let's just get rid of it. Let's just say let's just pretend that X is small, and then we'll check it. It's something kind of like the 5% rule or something, or 20% rule or something. So let's assume X is small. So plus or minus a small number doesn't really do much, but multiplying by a small number definitely does. So
Leonard Euler is like turning over in his
I
grave
know,
right
dude.
now.
this is
You're
so
right,
this is chemistry. This is chemistry for sure, dude. Okay, so this is gonna be is equal to X times 0.107 over 0.0157. So let's see what we get. Just see what we get for X, and then I think if X is determined to be only like 5% of this, then we're okay. Otherwise, yeah, you could solve it. It's a quadratic. It's just ugly. I don't want to do it. Okay, so 0.107 divided by 0.0157 equals that times 6 or times 4.5 e to the minus 4. It's 0.003. It's close. Do I believe in God? I believe in something. I believe there's a higher power of sorts. Yeah, for sure. I don't know if it's necessarily God or like, you know, Jesus or some dude with a beard up in the sky, but there's definitely something. I shouldn't like be on this world for all of my experiences, so something is definitely keeping me here. What's up, Justin?
Good
Good to see you, Phil.
I am your god. Fear me.
Fear me. Okay, so if that's X, if that's 0.03, it's 20% of this. So it may not be okay, but we're just going to pretend. Let's pretend X is equal to 0.03. So then that means that the amount of hydronium that is being dissociated and produced is equal to that. So then pH... Oh, nice. I'm glad, Failed Agent, that the doom-scrolling gods brought you here. So pH is equal to negative log of H3O+, which in this case is going to be the negative log of 0.00306. This is going to be very high. I'm a little scared for this, actually. This is going to be like a pH of like 2. Yeah. pH of 2.5. That's way too low. pH.
No more chemistry.
Ask an engineer, name 3 numbers. What's his answer? Oh, is this a joke? Wizard, what is it? Thank you, Akash. I appreciate it. Okay, I got 2.5. I do not think that's right. So let's see. This is again, you guys are so lucky. I mean, you're also like so severely screwed sometimes, but you also are lucky in that like I can have AI just run through this and I can learn from it and I can see like what I agree about it, what I don't. And then I'm actually gonna question it and be like, hey, okay, so here, yeah, the initial, so we were good with this. Good, the initial reaction is the neutralization. Cool, I'm fine with that. And I was cool with the conjugate base being formed. Oh, okay, cool. Okay, so actually we're not bad here. Okay, for nitrous acid, pKa is 3.35. Is that right? Okay, so I think we're actually on the right path. Let's see. Yeah, I see what they did there. They use Henderson-Hasselbalch. I don't think we're too far off, honestly, because then this conjugate base being formed is correct. That's what I said for this, and this is what's formed. Hey, what's up, CK Bubbles? New Twitch LA friend. Yeah, what's up? What's up, CK? Yeah, I was just talking about the photo they posted yesterday. It was super fun. For those that missed us earlier in the stream, we went to a Twitch meetup yesterday, which was really cool. And so these are all the people. I was at the Renaissance Fair right before it, so I was still in costume. And hey, Steve. What's up, Steve? Yeah, a lot of cool people. I met a lot of cool people at that. It was fun. Okay. You're at the Getty today? Oh, yes. The Getty's great. Wait, the Getty regular or the Getty Villa? I do like the Getty. It's a great like first date spot too, honestly. If you want to like take a girl to a museum.
My man.
It's pretty. The regular one, nice. Yeah. My friend lives like right behind the Getty Villa. He's in the whatever, I think the ADU of some super rich mansion, and like from his ADU looking over the balcony, you can see the Getty Villa like entrance. It's super cool. I'm like, man, you can just like walk down to the villa. Whoa, 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 whoa. The Getty is closing for renovations? Oh no. Wait. Oh, I didn't know about that. Oh dear. Bum, bum, bum.
And I hate to tell you this, but entropy is a thing.
Entropy is a thing. Chaos is too. Yeah.
Which
Oh.
is why they renovate.
They are. Oh, they're doing upgrades for the World Cup and the Olympics. Ah, that makes sense. Yeah. Wow, we got some cheers. Oh, thank you, Steve. You're G, dude. Thank you, dude.
Waiting for this.
Thanks, Steve. Appreciate you, dude. Bum, 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 bum.
I would have been there too, but I'm 8,000 miles away, so.
Yeah, we could get you at. They have a TwitchCon in Europe this year in Rotterdam.
Casual
I thought about going.
walking distance.
Yeah, casual. Yeah, just walk across the ocean, dude. You're good.
It's a short stroll.
Yeah, leisurely pace. Okay, let me get rid of this. I wanted to see. So I got the 0.00. I got the 5 times 10 to the minus 4. Is that 10 to the minus 4? Yeah. And then I also got the 0.00375. Something is just not adding up with this section. Henderson Hasselbalch is like a cheap trick you can use instead of ice if you're in like a certain region.
Is it the? It might be the. I think GPT is different KA. I thought.
Well, they said their PKA was 3.35, which I think makes sense because if I take the negative log.
We said our KA was 4.5 times 10 to the minus 4.
Which, I mean, when you do the log of that might make a bigger difference.
Yeah, but that's what PKA is, and that makes sense. Because look, yeah, that's just 3.3.
Oh, I see, yeah.
3.35, so that's fine.
Oh, yeah.
So their PKA is right. I want to know why my ice table is wrong.
Oh, I see.
Yeah, what they use is, it's called Henderson Hasselbalch. But again, this is kind of like just like a cheat trick.
Is what it is. Yeah. For figuring out what the you like the baby voice bubbles? It is funny. Yeah. I do need to drink water. Thank you, Peace. Yeah, I do need to drink a lot of water today.
My name is Jeff.
Where's Jeff, by the way? Jeff, where you at?
My name is Jeff.
AFG, what's going on, dog?
I'm also learning ice tables, bro. It's like crazy.
Yeah?
Yeah. I just started it. I just started the acid base unit. I don't know.
Oh, cool, dude. Yeah, I mean, it's a common thing that happens in chemistry around this time of the year.
Yeah, I don't know anything about buffers though yet. No, Ka, Kb, pH.
Well, wait. You have to have... No. The only reason you use ice tables is when you have a buffer. Because you have an equilibrium, is what you do. ICF...
I know, but, like, you can use it. You can use it in like basic. I mean, I don't know what a buffer is yet, but I still use ice tables.
Oh. Interesting. Well, well, okay. Ice table means you have a reaction that's happening in equilibrium, which means that you have like forward reaction, backwards reaction, and the most common like equilibrium reaction is a buffer.
Oh, actually.
Yeah. So you have, for instance, you have an acid here, a weak acid, which is reacting with water. Things do react with water. And what that does is that like auto-ionizes and creates H3O+.
Is that a weak acid? How is that a weak acid? Wait, what?
HNO2? Yeah, HNO2 is weak. Yeah.
Wait, isn't that nitric acid? Or
it's nitrous acid.
Oh, nitrous. Oh, nitric is HNO3.
Yeah. Well, let's look up. Nitrous acid, weak or strong?
No, nitrous is weak.
Nitrous is weak. What's nitric though?
Nitric is strong.
Nitric is strong. You're right. Yeah.
I confused the two.
Jeez, I was napping through this chemistry BS. Don't worry, Jeff, we'll get to math.
My name is Jeff.
Don't worry, we're gonna get to math. I just want to get this last little.
Jeff, I got a heater for him. That's a good one.
Yeah, Breasticles has a heater of a question for me, dude. Absolute heat.
A what question?
A heater. Like
heater?
like a difficult one. is what we're
Like
saying.
Do we not have any
very
questions
easy one.
from the chat?
Oh, we do.
like,
We have
any-
we have 7 questions. There's so many questions in chat. Like, yeah, the queue is quite long right now. This is the queue so far. I just keep getting distracted.
Brother, this guy stinks!
But it's all good. It's Sunday. I'm taking a leisurely pace answering questions today.
What soundboard do you have?
It's a custom soundboard. I created it. Yeah, I use
I know, but
Ableton.
what app is it?
Ableton.
Why
It-
don't
it's
you
it's like
voice-
it's like DJ producer software. The reason why I use Ableton is because my sound routing, for you guys to hear the soundboard in Discord and for people to also hear it on the stream, I have to like route the audio through like so many different like virtual devices. It's a mess, dude.
Oh shit, not good.
Yeah. But I don't know, I like the nerd type shit. Okay, let me just make sure what it says. Okay, conjugate base 0.107. I agree with that. Yes. Okay. And then this is gonna be plus x. This is minus x. You know what I think it is? I think it's because I don't think we're allowed to do this.
You're not that guy, pal. Trust me.
We're not allowed to do the minus x here because I'm not allowed to just negate it because 0.003 is 20% of 0.0015. So if you go to whenever you do this little like shorthand approximation, you have to check to see if the x you get is comparable to what you negated it around. So I negated it around 0.0157, and yeah, that's 20%.
Oh no.
So yeah,
Well, my teacher uses the 5% rule.
right, exactly. So yeah, so 20% is really bad.
Oh yeah, 5%
Yeah,
rule.
Yeah, but this is 20%.
Okay.
Of 0.0157. So you're not allowed to do that. So,
Do you also know that equation where like if the K value is pretty small, you can just use like to find the concentration, you can take the square root of the Ka times like the Ka times the concentration of the acid, the weak acid.
yeah, because eventually this just becomes like an x squared is what happens. Yeah.
Yeah. So it's just a short equation. You don't have to write down an ice table for that. I mean, like, you know, for that like the questions like those particularly, like when Ka is like, you know, at least less than 10 to the negative fifth.
Yes. Yeah, this is 10 to the minus 4. So I mean it's down there, but it's not like super down there. Okay.
Yeah.
We got to go the long way technically to do this, which would be I need to like multiply this through. This is going to become a quadratic. So I'm gonna, instead of doing this like by hand with algebra, I'm gonna like graph this. So I think I can do this with like Desmos. So we're gonna graph 4.5 e to the minus 4, and then we're gonna compare that right to x times 0.017 plus x. Divided by, and that's going to be 0.0157 minus x. There we go. Cool. Okay, and then I want to figure out where these intersect. Will it do it for me? I think I probably have to like set my whatever here. I got to set my settings here. Pretty. Y-axis needs to go from like let's say 0 to like, let's say 1 e to the minus 3 or 1 e to minus 3. How do I do that? 0.001 maybe 1, right?
No, it's because
Well,
no,
Desmos
it's
not
'cause
graph.
you-
Cause
yeah.
okay, I got you.
Yeah. Use all the numbers.
Yeah. Desmos doesn't like this. There you go.
Yeah, now you can. I mean, I'm pretty sure if you have like your normal Windows settings, you can still see it.
There we
It's
go. Okay,
just
now
gonna
we,
be-
yeah, great. Yeah, now we can see it. There we go. Okay. There's my x. So my x is, this is really small. What was that? 4 zeros and a 6 6. Okay.
So 6.6 times 10 to the negative fifth.
Yeah. Okay, great. And then I should be able to take the negative log of this. Right, and that gets me 4.18. Okay. So then I do negative log of 6.6 times 10 to the minus 5. And then that gets me 4.18. I think it's a nicer pH. What did ChatGPT get? Let's see, where was it? Yeah, they got 4.18. Okay, cool. We got the right answer. Nice. So, here, I'll copy this. This is a shortcut you could have used.
Well done.
I don't necessarily... I think it's... You want to get in the practice of using ice tables. So, don't always trust Henderson Hasselbalch to figure it out. But, yeah, this is a shortcut. Shortcut. What's up, Willie? Okay, cool. Alright, nice. Good question, Ace. There's an in the denominator, of course. An N in the denominator, of course? So here, this was attempt X is small. Approximation. And then we figured out this was a bad idea.
Oh no.
So then we had to do it the long way. So this was me graphing. You could have also done the quadratic equation.
Don't ever try like the x is small approximation unless like the k value is less than -10 to the -5, and like your initial
and your initial concentrations are small enough. Yeah.
Yeah, you're pretty small.
Yeah, I agree with that.
Because you usually end up more than 5%. Also, Dr. Gold, do you remember the equation for like when a capacitor discharges through like a non-uniform resistor rod?
Non-uniform? What? Wait, why would it be non-uniform?
No, not for chemistry, but I just had a question.
Oh. I mean, if you submit it, I can take a look at it, but I don't know about you're non-uniform in terms of what?
It's not I mean,
like how's it vary in time?
Yeah, like let's say you're given the length, the cross-sectional area, and like the resistivity function.
Oh, okay. Yeah, I mean, you just have to set up that differential equation and solve for it again. Yeah,
what is that? Do you know?
Yeah, it's like dq dt is equal to I, right? It's equal to like v over r.
No, but if you want to find like the total resistance.
Oh,
like to find like capacitance of it.
No, like I don't know. Okay, listen. It's like the capacitor is discharging through like a non-uniform resistor rod, and you're given the length, the cross-sectional area,
and the resistivity. Yeah, and then it's just rho L over A.
What is it?
Rho L over A is the resistance of the equivalent resistor to the whatever thing you have.
Okay, because okay.
You don't have to integrate unless the resistivity is also like non-uniform.
Oh no.
No, the resistivity is just like it's a function p of what am I saying p? Rho of x is rho initial times 1 plus alpha x, and you're given alpha.
Okay, well then you have to integrate over x, right? You have to integrate over the entire. You have to integrate over the entire length of the thing.
So from 0 to L, but what was the integrand?
It's integral of rho dx over a then.
Rho dx over a. Okay, thank you.
Because it's rho L over a, right?
Yeah.
And this is all again, and a may be a function of x as well, right? If the shape is non-uniform. Okay. Then it's rho which is a function of x, and then dx. Because integrating dx would just get you L.
So yeah, 1 over a. You take out the 1 over a.
Sure. If a doesn't depend on x, sure.
Yeah, okay.
All good. All right, nice. Good job, Ace. We marked your question as done. So that means it goes into our Discord. So here in the channel homework help, you'll see this was your question. There's a timestamp for like when we did it. And then also I'm going to drop in the screenshot. This was a doozy. Yeah, it was. But to be honest, Ace, it would have not been a doozy if you just used Henderson-Hasselbalch. So, yeah, this you definitely had to do. But once you got to this, you can use this. Because you do have a weak acid. I just didn't know like how much of the weak acid I had, that if it was okay. But yeah, once you have this, and this, you can just do this equation. You don't have to go through. It's nice to write this out to see how this all works. And then, you know, you check, oh, the small approximation, and they're like, okay, now I got to solve the quadratic. And then this is kind of the main thing, right? X is equal to the H3O plus concentration, and then the negative log of the H3O plus gets you the pH. I think that's the the learning parts of this question that you really want to know. You're so cooked for equilibrium? No. No, just do a couple practice questions. You'll be okay, dude. I know it seems like the hardest thing in chemistry, but it's not that bad. Okay. Cool. Let's go see whose question we're gonna solve through next. Bunch of people up there. Let's spin the wheel. See who's gonna win.
Let's go gambling!
And it's I'm sorry, breasticles.
I do apologize for this.
Jesus Christ, what is this?
It looks worse than it is.
Okay, we're gonna take a look at
At
this.
least.
Should I submit the Einstein-Cartan solution? Haven't checked myself. If you want to check it, I can submit it. I'm just letting you know. I just wanted to see if Free Gemini could go there. I don't even know what the sorry, I said Epstein. Einstein. I don't even know what the Einstein-Cartan equations are. Okay. All right. This is a very, very nasty integral that we're gonna try to solve.
Yes.
Okay.
Okay.
Jesus, what? And X and Y are inside the cosine as well?
Yeah, it works out easier in just a sec. So what we're actually first gonna do is we're going to apply a coordinate change to this with a two-dimensional Jacobian.
Nice.
Yeah,
Okay.
this is like your pre-test in calculus 3.
This is not a Calc 3 question.
This is a
no.
Calc 3 pre-test.
Wait, are you serious?
No,
Yeah, okay, good.
hell no.
Okay, so yeah, so this is an R3, which is like X, Y, and Z coordinates. I understand all that.
Factoring.
Well, factor. What?
You don't want to factor anything yet.
What, like difference of
There's
squares here?
No.
There's a
Like, you can factor it into a double integral and like an improper one.
Oh, you don't need to do that. First, we want to do a coordinate change.
Yeah, let's do coordinate change. I agree with the coordinate change probably.
There's a non-linear map, a very specific one that makes this a lot easier.
Okay. Okay, what's my coordinate change going to be?
How we get it. So it technically, I'll explain kind of where it comes from first. So our map is going to be going from z to z squared. Right now, this is the real plane, but it's easier to imagine it if we imagine our complex numbers first, just because the manipulation works out a bit better, right? So when we have a complex number z, right, we write it as x plus iy.
Mm-hmm.
Right, and then when we square it, we'll get to be x squared minus y squared plus 2xy.
Got you.
And then the 2xy is multiplied by I.
Yeah, 2xy.
Yeah.
Yeah, right. Okay.
Mm-hmm. And so
Okay.
that's technically our mapping from z squared. Since we're doing it in the real plane, we're just going to say our u is going to be x squared minus y squared, and then our v is going to be 2xy.
Okay. And
And then this
then
also leads us into one thing we're going to have to worry about slightly later in the Jacobian, This mapping is 2 to 1. Normally, our Jacobian only refers to a 1-to-1
1-to-1.
function, or
Yeah,
sorry,
yeah.
a 1-to-1 mapping,
Uh-huh.
right? But because we're doing z squared, there's a plus and a minus that we have to worry about. But we don't have to deal with that later until we do the Jacobian, and it's just a factor of 2, so it's not that big of a deal. But
Okay.
from that coordinate change offer, if we do know that is something that we have to
Yeah. So in
concern
usual
ourselves
calculus, for those that are wondering, this usually gets done when you're going from like Cartesian to polar, or sometimes you can come up with your own coordinate changes for like Green's theorem and stuff, and you do have to figure out that like Jacobian, which is, I don't know, it's usually like r theta cross r phi or something, and then you do this, right? And then that goes in, and it's a way to convert like dx, dy, dz into like some new coordinate, like for instance d theta, dr, d phi, or whatnot. In this case, we're coming up with our own coordinate system that's not really standard. Which, okay, so is this gonna be du, dv, dz?
Yeah, we don't need to worry about dz. We're gonna leave z as the same. All right, so we're really just changing our coordinate system in x and y, but z is fine. We don't need to concern ourselves with z. All the substitutions work fine without having to concern ourselves with z.
What does this mean then? Sorry, z goes to z squared. Sorry.
Z
this
being
is the complex numbers. Complex numbers.
Yeah, that's technically not like our coordinate change necessarily.
Yeah.
That's just it's a lot more clear referring to the complex numbers. Because squaring our coordinates like that makes like a clear,
Okay. Here, I'll say
it
in the
makes
complex.
it more clear.
In the complex plane, going from one complex number to like a two-dimensional complex number gets you this, I guess. Or when you square it becomes.
Well, it's still two-dimensional, but we're basically doing a map where it's kind of hard to explain without like having done. Well, I have done. I don't know if you have, but like conformal mappings in complex analysis. Yeah, so sometimes we'll like you'll do a map where like you have a function in what's basically a Cartesian plane, right? And we call that your u, or I think it's z. I forget exactly what they are, but then you have another plane called your w plane under a mapping, and you could kind of jump between it. There's a lot that like goes into it. Like it helps with the Laplace equation, like if you've heard in fluid dynamics of the Joukowsky airfoil. I don't know if I pronounced it right.
Joukowsky.
They say it's a really, I'd say it's a fluids question about how air goes over a foil. It's a Russian dude that helps you spell it. It's like
the Joukowsky transform.
Yeah. So that bottom one is like a pain in the ass to figure out how fluid flows around it. But when you use a Laplace equation, it's an invariant under conformal mapping, so you could look at how it behaves around a circle, which is a lot easier to figure out, and then apply a conformal mapping to it and get that. You can do the same thing, right, to get to capacitance for a cylindrical capacitor. If you apply the Laplace equation to a normal parallel plate capacitor, since it's invariant, you can do a mapping to convert that solution into a cylindrical capacitor, or theoretically.
I see. So it's a way to like look at something in like some weird geometry and then like make it look like something that's simple.
Yeah, and in essence, that's what's happening in this case. But we're like squaring our coordinate system. In essence, it's not a very like intuitive idea. But
okay. All right. So do I need to calculate dv? I need to calculate.
Yeah, your Jacobian, and you just need to do it in 2 dimensions so that you don't have to do some crazy.
Okay, so I gotta calculate this.
Like,
I gotta calculate. What is it? I think it's ux cross uy, or no? What is it? No. Xy cross uv.
I think so. That sounds correct.
I think it's x.
It's a mix of your partials, so it should go 2x, negative 2y, 2y, 2x.
Oh, wait, no. Sorry, it's... Maybe it's this. Maybe it's this. I think it's... Or you know what they say? Sorry, they say it's like RU cross RV, I think is what they say. This is the Jacobian. Which, yes, is a matrix. Which is going to be du dx, right?
Mhm.
And then is it du dy? And then it's
yes.
dv dx, dv dy, I think. Yeah. Okay, cool.
Yeah.
I see, but we're not doing this. We're not doing this in 3 coordinates.
No, we're just doing the
Oh. Yeah, usually this would be a function of like something else with z as well. And so then I'd have to, then I actually have to take a full cross product.
two. Yeah.
Calcium
Yeah,
market,
that's
how
a
many
mix
minutes?
of. It's mostly a mix of. I originally wrote the problem in 2 dimensions, and I was like, "Fuck it, let's see if I can make this harder by making it 3 dimensions." And then I didn't feel like changing it that much to figure out the rest.
Okay. And then dv dx, this would be 2y, and then dv dy would be 2x. Okay.
Mm.
So then the determinant of this is going to be 4, and we're going to say x squared minus y squared.
It should be x squared plus y squared.
Ah, right, there's a minus there. Yes. Okay, cool. So new integral. X squared plus y squared, interesting. So is that going to be, oh man. But I have x squared minus y squared. how do I deal with this?
Hold up, I'm looking.
Wait,
it just disappears, yeah, because you're du dv is equal to 4x plus y squared.
Okay. Sorry, what were we saying?
You end up that from the Jacobian you get du dv equals 4.
I
x squared
see.
plus y squared.
Oh, it's right here. Okay. Okay, wait. All right, so du, I need to calculate these things, I think, right? Du is equal to 2x dx minus 2y dy. I think I have to write that, no? And then dv is equal to 2y dx plus 2x dy. And then z stays the same. Okay, so let's just leave it here for now. We're just going to say x squared plus y squared. And then this is going to be x squared minus y squared. So that's going to be u squared plus b squared. And then this is going to be z squared plus c squared. And then this is going to be e to the negative a. Well, I don't like this x squared plus y squared plus. I really don't like this breasticles. I don't know how this is going to come out.
It does. You just gotta be.
I gotta trust.
Be patient with it.
All right, I'm
Yeah.
gonna trust. Okay. Okay. So this is x squared plus y squared plus c squared. Great. And then cosine of 2 lambda xy. Oh, okay, so that's cosine of lambda v. That's nice. We like that. And then all this is a mess. Because how am I going to rewrite... do I got to solve this? This is weird, though. What?
Oh, no, you don't need to do it like that. So, right, we see how we already showed that...
oh, I see. Oh, we don't need this. Sorry.
The whole, like, x squared, y squared, all that shit.
I see.
You can
you can just say this is equal to... Oh, I think I remember how this works.
Yeah, you take... It's like a bigger u sub, in essence.
Yeah, with the Jacobian. I see.
The x squared plus y squared gets pulled into the...
So this becomes 1 over... I see. Okay. This now tells me that this whole thing, du dv, is now equal to something in terms of xy dx dy. I see. I see. Okay, wait, no. Is it this, or is it? It's usually you do
That
1 divided by it.
So this times dx dy is
Yes.
equal to du dv.
Got you. That's what I wanted. That's what I want to say.
Yes.
Yes. Okay, now I remember. Yes. Okay. So this thing right here shows up with this over here. Got you. Okay. So this is gonna go away, and we're just gonna get 1 over 4, right?
Mhm.
Du dv. Okay, cool. Okay, I'm there. I still don't like this. Still don't like having x squared plus y squared on the top there. But I'm gonna trust. Okay. 1/4 integral e to the negative a, all this garbage.
Mhm.
Cosine lambda v. And then we got that. I think AFG says he solved it another way. What'd you do here? Oh, he just broke it up into integral parts of X, Y, and Z. That's smart. Okay, maybe. All right. All right, what do we do next?
That's what we're gonna do in a second.
That's what we're going to do? Yeah, okay, I see. So...
Yeah, so also we know that x squared plus y squared is equal to u plus v squared.
I thought I was going to come up with some of that. Yeah. Okay, so from this, u squared plus v squared. Right, okay. That would be equal to x squared minus y squared squared plus 2xy squared, right? And this is going to get me let me think, sorry. That's going to get me x squared minus y squared blah, 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 blah. No, that's x to the 4th minus y to the 4th minus 2x squared y squared. But then we have plus.
Should be plus y to
plus.
the 4th.
Yep, sorry, yep, plus. And then this is plus. Oh wait, interesting.
That's just plus 4x squared y squared. And
Yes,
then
okay. So that cancels out
your
one
x
of those.
squared y squareds cancel out, and then that is the same as x squared plus y squared.
Wait one sec. This is going to be plus 2x squared y squared. This is the same, right, okay, as x plus y, x squared, y squared, squared, squared. Gotcha. Okay,
Yep.
cool. Gotcha, okay. So this is u squared minus v squared. Okay. So now I'm going to plus, sorry. So now I'm going to separate this in terms of du, dv, and, oh, I forgot there's a dz here as well.
Yes.
Okay, du, dv, dz. I can separate this integral out. So 1/4. We'll do the one just in terms of du and dv. But I also have this on the bottom in terms of u and z though. That's kind of fucking me up though.
That'll make sense in just a second.
Dude, all this stuff is like no. Yeah, all this stuff I would say like absolutely not. This does not look like it's gonna be the right path, and then somehow I just trust that something's gonna like it's gonna
It all works out.
it all works out in the end. All right, fine, dude. All right, okay. All right, I'm gonna break this up as e to the negative a u squared plus v squared cosine lambda v, and then this is gonna be over all this. And then we're going to say there's then another integral.
Yeah, and
Just
you can
return-
do that for all of them. All of them can be written as their own, including the u and the v. You can break them apart. But
Oh, these can be broken up as well?
Yeah, because they're each like multiples. Because e to the u squared plus v squared can just be e to the u squared.
Okay.
Right, and then
So now we're going to, split integral. Okay, some variables. Okay. So.
also I forgot the 1/4 should be a 1/2. That's just from the we were talking about earlier the 2-to-1 mapping. That's just that factor of 2 that we have to consider.
Oh.
I forgot about that.
Okay. But 2-to-1 mapping gives a 1/2. I would have never known that.
Yeah, I forget where exactly it's supposed to be like inserted into the equation. I just remember that I threw in a 2 there to account for it.
Okay.
No z squared in this one.
No z squared.
Yeah, no. Well, no, the z squared is there, but that term doesn't need to be in this integral.
Got you. Because this one only needs to have stuff
Just
in
that
u.
term, yes.
Got you. Okay. So this is gonna be the du term, and then we're gonna have e to the negative a v squared over. Oh, I don't need any of those either, right? And this is just cosine lambda v. This is dv.
Yep.
And then we have the integral of e to the negative a z squared over z squared plus c squared dz. Okay.
Yep.
Okay,
And
I agree with
then-
this.
Here's where first we can easily figure out our middle integral, because technically it's right. It's on R3, so that just means from negative infinity to infinity. Right. So that is going to be
This
our,
is integration by parts, like twice or whatever.
no, we can actually just do it from the Fourier transform. Right. So
Oh,
if
okay.
you recognize that the Fourier transform of a Gaussian,
Mhm.
you can just go straight from it.
Okay. What does it become? I get it. I see the e to the whatever squared, and then the cosine.
Yeah, and then it's just you just take the real part of it since we're working with the real numbers. And so you get that it's the square root of pi over a, and then e to the negative lambda squared divided by 4a.
Okay.
And then we can have that in there, and then we're going to define a function. We get to use not the plus transform, Feynman's technique here.
Mhm.
We're going to define a function j for our outer integrals, because if you look, you can kind of recognize they look almost the exact same. They just have like
Yeah, they just have
a
just
couple
this
of
and
different
this and
variables.
this and this. Yeah.
Yeah, so they're functionally like almost the same. So we can write a function j in terms of a, because we have a in both of them,
Mm-hmm.
and then beta, because beta is what's different.
Okay.
And then we're going to call that both sides of the integral, so from negative infinity to infinity, of e to the negative at squared over t squared plus b squared, or beta squared. So
All right. So I'm gonna say j of a and beta is e to the negative a
the integral of it.
is equal to the integral of e to the negative a t squared over, I get it, this is t squared plus beta squared dt. Okay.
Because now whatever RT is,
Sure.
whether it's U or Z, can get determined from that function J.
Right. Okay.
And then
so this is j j a b. Right. So this part is now j a comma b. And this part is j a comma c. Right.
Yes.
Cool.
It's good.
Okay.
So then we can figure out the solution to our function j, right, in terms of beta, using Feynman's technique. So we're going to take our partial derivative with respect to a of j.
Okay, so I'm going to do dj dA equal to the integral of ddA e to the negative at squared over t squared plus beta squared dt. dDA is going to pull down a negative t squared.
Yep.
T squared plus beta squared. Okay. All right.
All right, and then we can use through a little bit of algebra, right, by just adding and subtracting beta. We get that t squared over t squared plus beta squared, right? There's still the e to the negative a t squared, but if we ignore that for a sec to do the algebra, we can get that it's equal to 1 minus beta squared over t squared plus beta squared. So we're just breaking up. Yeah. So the exponential is going to be multiplied, but we're not going to worry about simplifying that necessarily. But that rational part, right, can be broken up into a 1 minus by adding and subtracting beta on both sides. See how if you were to,
I gotta think, yeah. So I have negative t squared over t squared plus beta squared. And you're saying if I add beta squared here and subtract beta squared?
Yeah. Because see how if you break up that grouping into the t plus beta squared, the t plus beta squared cancels, and you get a 1. And then just subtracting beta squared over t squared plus beta squared.
All good, Jeff. Okay, 1 second. T squared plus beta squared.
Yeah, so you can ignore the negative there for now. You can just throw that out front.
Ooh, okay. Sure.
Because it's just multiplied by anything.
Okay.
Right. So if you you can break the fraction into two
Oh, I see
fractions,
it.
right?
I see it.
Yeah,
Okay.
yeah, and the
Okay,
t
gotcha.
squared, beta squared cancels, and then it works out relatively easily.
I see it. T squared plus beta squared. And then we're gonna say times 1 minus. Wait, does that work? Sorry.
Oh, not times 1 minus. It's another fraction because we're just adding and subtracting.
Wait, you want to add and subtract down here as well?
No. So right above it's fine. Divide what you have already written right below it. Divide it by t squared plus beta squared.
This?
No, the next line. Right below it. The one that's half written. Yeah.
Okay.
Divide what you've written there by t squared plus beta squared.
Oh, minus
then,
beta squared over
yeah.
t squared plus beta squared. Oh, I see what you're saying.
Yeah, and then they cancel out. And then you get
Okay.
a 1 minus.
One minus beta squared over t squared plus beta squared. Okay, cool.
And then you can break that into 2 integrals. It shouldn't have anything dividing on the left one.
Oh, yeah, you're right.
And then it should be minus, not a plus.
Well, you have a minus outside here. So I put minus, then I put minus minus plus.
Oh, I see. I see what you did. And then beta is a constant, so we can bring that out front of our integral on the right.
Okay.
And then you'll notice that that's just j, right? We're back at having a j. So in the next step, we can rewrite that integral on the right as just j, which we've defined. And then our integral on the left is a Gaussian.
Okay. J of A and B.
Mhm.
And this is all equal to dj dA.
Yep. And then
And this is a Gaussian, which becomes what?
it's
Pi
square
over
root
2
of
or something?
pi over a. Pi over a.
Square root of pi over A.
Mhm.
Put a
And then you can
minus.
just solve the ODE with an integrating factor. That gets you to
Alright, I will agree with AFG. I'm fucking done at this point. So
Yeah.
it's just too much.
I told you it was a year.
Okay, but just to be fair to everyone else, I can't spend like 40
Yeah.
fucking minutes on this question. Cause okay. I get that this would then be, it's cool. I appreciate you designing like marathon type questions, but there's so much. Cause yes, now I have to do,
Yeah, there is a
now I
lot.
gotta do Diffie Q to
Yeah.
like get to this.
And then I think
How much more is left?
quite a bit. You'd have to solve for J. Once
Okay.
you solve for J, you choose your boundary conditions for your integration in solving J.
Okay.
And then you'd have to convert all the way into a error function and then apply it to it. And inevitably you get to that.
Ooh, which I think is pretty close to what AFG got. AFG, did you get the same thing?
Yeah, I believe I see.
Nice, AFG.
Let me see.
Alright, I'm gonna call this question done just for now. So we can move on.
It's because J turns out to become an error function. So J turns out in terms of beta to be equal to pi divided by beta e to the a beta squared complementary error function of beta root a. And then you apply it to both of them.
Nice. Wait, why did I mark Justin's as done? What the fuck? I hit the wrong one. Feet. What's up, Fork? Nice. Okay, cool. Yeah, no, it's cool. There's a lot of stuff to go in there. I would learn a lot. Just a little bit of time. AFG came up with something cool though as well, so I'm glad you guys are both getting to it. I'm nearly there on the queue. Yeah. All right. Well, let's see. I accidentally marked Justin's as already done. I shouldn't have done that. Sorry, the code was messed up. Okay. What was Justin's? Let me see. Let me do Justin's because I fucked up and accidentally hit his. I need to put like an undo function, I think, on this. All right. Let's see. Material is blown into cart A from cart B at a rate of B kilograms per second. The material leaves the chute vertically downward so that it has the same horizontal velocity. Wait, the material leaves the chute vertically downward so that it has the same horizontal velocity as B. At the moment of interest, cart A has mass m and velocity v as shown. Find dv dt, the instantaneous acceleration of A. Are they connected? Or I guess not. Okay, well, I mean, I know of this, right? So if P is equal to MV, we're going to say that like dp/dt is equal to, this is going to be V dm/dt plus, what was that? M dv/dt. Usually M doesn't change. So this is just the equation of momentum. And then I think change in momentum is also equal to, or dp/dt has to be 0, I guess, if there's not any external forces on this. So maybe this has to be 0, I think. Because in terms of the system, there's no force acting on the wheels of the ground and the stuff. So it's just like you're just exchanging things within like containers, and so the center of mass change in momentum has to be 0. There's no external force on this whole system. So I think this is 0. It's like if you're on a boat and you start like pouring sand from one cup to another, the boat doesn't move. If you start pouring sand outside the boat, then the boat starts to move. So I think in this case, we think about the system of the two carts. And they say they have the same horizontal velocity. Wait. The material leaves the chute vertically downwards, so it has the same horizontal velocity. Oh, as the cart. Oh, so they're not connected though either. Okay. Mass m and velocity v is shown. Find dv/dt. Instantaneous acceleration of a. I still want to maybe say it's this. I don't know. I'm tempted. Because dm/dt is nice. dm/dt is just this. That's the amount of mass that's being added. V would then be the velocity V of this thing. And then you can solve for dv/dt. And then you have m as m. What's up, Phenomenon?
Good job.
Alright, let me just throw this in the chat real quick. I just want to see what chat says. People be giving me hard questions today. Yeah, let cart A plus the mass plus material already in the system at one instance. Since the chute sends the material straight down towards the end, its horizontal speed matches cart B, so the incoming mass brings horizontal momentum. Now write horizontal momentum for cart A over this short time. Initial momentum is mv. Okay. I think I see this. The incoming material added during this time is BDT, and before joining, cart A carried the horizontal momentum BDT times U. So conservation momentum of the so you have to conserve the entire system. Yeah. But I think for the entire system, you can't have any change in momentum. Interesting. MV BDTU equals M plus BDT. Okay. This is kind of what I was saying. The momentum for the whole system has to not change. Okay. Yeah. All right. I think I got this. Okay. So let's say like so momentum before has to equal momentum afterwards. Yeah, exactly. Yeah. So before, and then did they tell us the did they tell us the mass of cart B? Don't I need to know the momentum of mass of cart B? Or let's just say it has mass X. Okay. So momentum before you have X times mu plus M times V. Right? And then afterwards some short time dt. The momentum of this one will now be M plus BDT. So this is the rate at which mass is being added to this. And then this will be the amount of time that has been added. And so that'll be the new mass. And then this will be times the new velocity. Oh, sorry. I did left to right. I should have done it this way. Let's do it this way. MV plus XU. Yeah, exactly. Yeah. Both exchanges in with one cart, so they cancel, right? Yeah. This is big MV. This is going to be XU. But then afterwards, you're going to have M plus BDT. And then that's going to be times some new velocity. So this would be V plus dVdt. What's up, Bella? I think. And then this is going to be X minus BDT. But then that's going to have a velocity of U plus du dt. Momentum leaves proportionally with the mass. Yeah. Momentum is leaving one and getting dropped on the other, but the whole system, the momentum has to be the same, right? Because there's no external forces. It's just like if you're thinking about within the two carts, they're just transferring. They're just like it's like the ice skaters. If two ice skaters like push off on each other, there's no change in the total momentum of the ice skaters. Oh, they just say plus VDV. Oh, okay, cool. Or they don't put the DT on it, I guess. That does make sense, actually. Sorry. Yeah, there we go. That's what I meant to say. Yeah, Newton's second law, right, Pete? Yeah. Right, okay. Okay. So I do see some things that'll cancel, right? So MV will cancel with like MV. And then XU here will cancel out with XU. And then I think I think what's going to happen, so I'm going to get 0 is equal to B B dt dV plus MdV. And then, yes, and then there's also V plus V B dt. Good, yep. And then the same thing here. So we're going to have plus X du minus B du dt. And then minus Bu dt. YouTube's a shit. What's up, Henry? Okay, and then, okay, this is the other argument that gets made. And this is a thing we do in physics a lot. We say, like, to, like, what order do I care about? I can say anything that has two differentials in it. So, for instance, this is like a small change in time. This is a small change in velocity. Those are two very small changes. And small changes squared are basically 0. Exactly. Yeah, pizza. Yeah, dt dv is very tiny. Yeah, that's what we say. This, again, math people hate this. But we do this in physics a lot. We're just going to say, oh, well, those things just go away. Okay, so now I'm going to say 0 is equal to m dv plus vb dt plus x du minus bu dt. I feel like there should have been another x somewhere. Feet, yes. Okay. And then what am I looking for? I'm looking for dv dt. Okay. What are we going to do with this x? Yes. mv plus b dt. Okay, bu dt is mdv plus, yeah, okay. Yeah, chat hasn't considered the mass of this. I don't know why. Yeah. And then they just solve, they just divide. So they see a b u minus v. Oh, I see. Maybe we could put this over as well. So bu dt minus vb dt is equal to all this. It's hallucinating. Sometimes it is. Okay. But then what did I want? I want dv dt. Okay, so then I can factor out a dt here. So I can say b u minus v dt is equal to m dv plus x du. And then I can divide by dt. So I can say b u minus v minus x du dt is equal to m dv dt. So then, yeah, I think it's b u minus v over m minus x over m du dt is equal to dv dt. Okay, cool. All right. All right. So I guess this looks pretty similar to what chat got for the first part, at least. Bu minus v over m, yeah, great. The question is this term right here. Which you could ignore if x is small. Or if du dt is small. So I guess it depends on, like, maybe they make the approximation that the change in the the change in the velocity of the blower car is very, very small. Yeah. The instantaneous acceleration of A was 0 all along. Wow. Not exactly 0. Well, they said that the material that leaves the chute vertically downwards, so it has the same horizontal velocity. Oh, you're actually in. Oh, you're so right, actually. Pete's 10. Yes, okay. Okay, I see what you're saying. There's the additional turn. Well, yes, I see. There's also, we forgot the momentum of the dirt, right? We forgot the momentum of the dirt that's coming down. So that is going to be, right? That's going to be equal to BDT, right? That's the amount of mass that gets dropped down. And then that is going BDT times U. Well, it says the material leaves the chute vertically downwards, so it has the same horizontal velocity as cart B U. But it's still momentum then, right? Right, I think this is still moving like that. So actually you just get 0 equals 0. Right, because once we do this goes away. Yeah, yeah. But the material does leave the chute vertically downwards, but they say it has the same horizontal velocity. So it is leaving downwards, but it still has velocity with it. So in the frame of the cars, it doesn't look like, I guess, it's dropping, right? Yeah, there's also a horizontal component. Yeah, exactly. Which I feel like this would then eventually end up canceling this one out. So then we wouldn't get our BUDT. Let's see. Let's see what chat says. Let car A plus the material already inside it be the system. At one instant, the mass of the cart is m, the velocity cart is v. Yeah. Material enters at a rate b. Incoming material has a horizontal velocity u just before it lands at A. Okay. Since the chute sends the material straight downwards towards the end, its horizontal speed matches cart B, so that the incoming mass brings in horizontal at a rate of bu. I see. So they don't. Okay. So they don't even. Okay. I think I see it. I see how they're doing this. This is actually kind of cool. So let's try it another way. We're only gonna look at what's happening here. Okay. So let's consider. Let's consider this is A, right? And you had whatever the chute. Okay. And you're going to have some amount of dirt here. Right? And then you also have the dirt that's already here. Let's put this in like blue. Okay. And this thing is traveling. So this dirt, right? This dirt is traveling at velocity v. This dirt is traveling technically at velocity u. Right? And the amount of velocity, the amount of dirt here is equal to BDT. Okay? So what we're saying is that this is now before. This is why you don't even have to consider the mass of the other one. Okay, and then afterwards, this is a really tricky question. I mean, props to whoever gave me this one. So now this dirt has fallen, right? And it becomes one with the cart. And now these two things together are traveling at a new velocity, which is going to be equal to v plus dv. It's going to be v plus dv. Does that make sense? But now, so this was bdt, and this was mass m, but now they're together. So now this mass altogether is equal to m plus bdt. Okay? So before, you have ub dt plus mv. Afterwards, you have m plus bdt moving at velocity v plus dv. And now you set these two things equal to each other. Okay, I think I get this. So ub dt plus mv is equal to mv plus mdv plus vb dt plus b dt dv. This we're going to get rid of. I see. And then I'm going to group all my dt terms. This is actually kind of cool. I understand this now. Good job, chat. This is ub minus vb dt plus mv. Oh, mv and mv cancel, right? Beautiful. Okay. Yes, and then this is equal to mdv. Aha. So dv dt is equal to b u minus v all over m. Wow, that's cool. Nice. Uh-huh. That's a very cool question. So yeah, instead of thinking about the two carts separately, you had to think about just like one cart individually, and then what was happening to that, like that packet of dirt right before, when it was like inside the cart but like hadn't hit the cart yet, and then once it hits, the amount of dirt and the amount of dirt that's already there equilibrate to like a new velocity, which is v plus dv. It's really fun. This is actually a really cool question. Thanks. Who is it? This was Justin? Justin? Good question, Justin. Yeah, I thought it was fun too. Okay, nice. Great. Alright, I'll put that in our Discord there. So there it is. If you ever want to look at it, get a little bit more help, it's cool. Alright, let's go find another question to go do. Spin the wheel. Who's going to win?
Let's go gambling!
Cheese! Cheese pizza. Cheese pizza, it's you. Oh, this is an interesting integral. Okay. Is this a Bresco level integral?
My name is Jeff.
It's close, but there's just if you remember it comes from your derivative structure. I remember looking at this one, I think yesterday, or not yesterday, last stream. I think you submitted it.
It comes from derivative structure. I guess this kind of looks like a chain rule of some sorts, maybe on the bottom. I don't know.
Yeah.
Or not a chain rule,
See if I
like a
can
product rule maybe.
find the word. Let's see.
Oh, wait. Okay, wait. I think x sine of x plus cosine of x is the same thing as ddx of x cosine of x. Except I need a minus in there somewhere, right? So the derivative of this, right, would be derivative of the first times the second. That's just the cosine of x part. And then, yeah, it's a product rule, right? Yeah. But you do have to do something before that.
Oh no.
Oh no, we do have to do something before
Yeah,
that.
I'm trying to remember what the I did it. I'm just like I'm trying to remember what it is and searching for where I did it. And I have a tendency to write shit down on scrap paper and then throw it across the room and never find it again.
Oh
And
no.
this
Be
is
gone.
one of them.
Be gone.
But I know it's I think it's A or D if I remember correctly.
A? Oh, the answer is yeah. Okay.
Yeah, I believe so.
What do we have to do first?
Yeah. Okay.
Are we gonna convert this into a double integral, maybe?
I don't think you have to. I think it comes like directly from the derivative structure to me. I'm gonna throw it in GPT real quick and remember what I did. But,
Thank you, Fembox. We can multiply divide by cosine of x on the top and bottom.
I remember working on it, and it comes from the derivative structure. You basically just get a derivative that cancels out. But
I mean, couldn't I like reverse engineer these and like just start taking the derivative of all of them to see what I get?
yeah, you could technically do that too.
You just keep taking the derivative. Till figure it out. All right. It's not fun that way. I guess it's not. Multiply divide by cosine of x. Wait, multiply and divide? Or you want to? Okay, let's try that.
Oh, I remember.
All right, x cosine of x over. We're gonna say x sine x cosine of x plus cosine squared of x. Okay, this is still all squared though. We get x secant x. Wait a minute. We can multiply divide by cosine of x. Oh,
you can also, if you consider ddx of x, basically what everything you have in the center or the integrand, multiplied by a secant of x.
let me think. Don't put the cosine x inside the square. What? Cosine x, cosine x. Okay. And then you're gonna say this is the same thing as x squared. I guess we're gonna leave the denominator where it is for now, I guess. X sine x plus cosine of x squared. And then this is gonna be cosine of x, and then 1 over cosine x is secant of x. Right, okay.
Yeah.
And then because I have x squared, I can distribute it to like kind of both of them. So I can say it's the same thing as x cosine of x, x secant of x, all over x sine of x plus cosine of x squared. Okay. Now I want to do integration by parts. How do you find the questions later? Everything's always in our Discord, Fem. So every question that doesn't get solved during the time will get put here into the homework help channel. And so there's a bunch in here if you ever want to like go through and help out with them. Some of them haven't been answered yet, so if anyone is ever like looking for like things to do on their stream, these are all the questions that get submitted to our stuff. Okay. It says x cosine of x and the denominator part is integrable. Yeah, got you. Making noise, stop. Okay. Oh, okay. I think I see. It's a teeny bit lengthy, he says. You guys give me lengthy questions today. This integral is doable. Because I'm going to say u is equal to x cosine of x, I guess. And then what? du is equal to cosine x minus x sine x dx. The other way around. Yes, Howard, you can do double integrals for sure. This is not a double integral. It's just a single integral. Integration by parts. Usually I need to pick one thing I know how to integrate and one thing I know how to derive. You're saying I already know how to integrate this? And then I'm going to derive this? I don't know if that's going to work. I know how to integrate this? How do I know how to integrate that? You're going to say dv is equal to x cosine of x over x sine of x plus cosine of x squared dx. And then you're going to say that u is equal to okay. Well, okay. Sorry. Is the u and the v from the integration by parts, or is the u and v for me like now doing the integral of the integration by parts part? Because now you're saying for this, u equals x sine x plus cosine of x. What level is this? This is just like retard level, like math. It's very difficult. It's tricky. Yeah. It's you do not need to do this in a regular high school class. It's just fun for the sake of it being fun. Okay. X sine of x, d of this is... Oh, man. That's sine of x dx. Wait, that's another, wait, what? What? Yeah, that's sine of x dx plus or minus x cosine of x dx minus sine of x dx. Yeah, okay, so this does cancel out at least. Sorry, this is plus. Yeah. Alright, so du is equal to x cosine of x dx. Oh, and that shows up on the top. Cool. Alright, so then v is equal to so this is this is just 1 over u. So negative 1 over x sine of x plus cosine of x. Okay. Okay, but then u has to equal this part, I guess, right? This has to be x secant of x. And so this is a different du from here. This is equal to secant x tan x plus secant of x. And this is all dx. So then, right, derivative of secant secant tan. Derivative of x is 1 secant of x. Okay, so then it's uv. So that's minus x secant of x all over x sine of x plus cosine of x. Minus, so minus is plus, so plus the integral of secant of x tangent of x plus secant of x all over x sine x plus cosine x. Okay. This is still dx though. Oh, was there some squared shit going on? No. No, I think we're okay. Okay, you want me to take... I can pull out a secant. I don't think I can pull out a secant squared. I think it's just a secant.
I would actually break, because you have the addition there. What I would do is actually break it into two integrals.
You mean here?
Probably. Yeah, but see how we have secant tan?
Yeah.
I suspect you could do a u sub there.
Okay. Yeah, okay. I see this as secant. You would break it up into like this one over this one plus this one over this one.
Yeah, I don't know if it would work exactly. But that, I mean, that catches my eye that, right, we have a secant
I
x
just
tan x.
I just don't like this integral. This one. This one like sucks. Because I need to get x cosine of x again if I'm gonna be able to do it. Pizza is very insistent that we take secant squared out of the top. Okay, I'll do it. But I will admit this would not be intuitive. And I'm becoming less and less of a fan of like unique tricks that I would never come up with. But I guess that's how all math works, is you don't know things until you've like used them before. And so now maybe I would know like to do this later. Maybe. I don't know. I guess like, you know, Feynman's trick is technically a trick that
Technically it's a rule. It's actually technically the Leibniz integral rule. But Leibniz like came up with it, and then he was like, "Yeah, I'm not gonna do shit with this." And then Feynman was doing his thing, and was like, "Yeah, turns out they were used for it."
Okay, I think I got this. But how does that help me? Pulling out secant squared. Break it all down into sine and cosine. I do usually like doing that. Tangent is sine over cosine. Secant is 1 over cosine. So this is just gonna be okay. I see what's gonna happen. This is actually really cute. How did they come up with these? I see what happens. Do you see this, Rascals? This is gonna become cosine of x. This is gonna be
yeah, I see.
right, because this is sine over cosine. Sorry, no, this is gonna be sine of x plus cosine of x. Yeah, and there should be another x somewhere. Oh yeah, from here. Yep, fucked up. You're right. There should be another x there. When I took the derivative of secant tan, yep. Cool. Yes. Yes. Okay, I see where this is going. Wow. It's pretty that it works out like that, but bro, I would have never seen this.
Yeah, I just reverse engineered it from like.
Yeah.
You're not that guy, bro. Trust me. You're not that guy.
Okay, because then this is going to cancel. And then integral of secant squared is equal to tangent, right?
Yeah.
So bada bing. We have tangent of x minus all this shit. Minus x secant of x over x sine x plus cosine of x. Which one was it? X sine, so minus x secant of x. I think it was answer choice A. Yeah?
Yeah, I think so.
Wow. Very cool. Cool question, pizza. It's fun to see how these integrals work out sometimes. I felt like I was kind of like really shooting in the dark. I was like, just like, man, like what's gonna hit? And then if you have some guidance like what the answer is, it's cool to work through and see how that happens. But man, so like this first trick here, I don't even think I would have. I wouldn't have known to do that. It's very unique that happens. Yeah, cool. It's a cool question. I appreciate it. All right, let's go spin the next winner.
Let's go gambling!
Jazzy!
That's dope!
Congratulations, Jazzy. Oh, wow, this is fun. This is equilibrium for chem, I think. Okay. At a particular temperature, K equals 3.21. If all four gases initially had concentrations of 0.8, calculate the equilibrium concentrations of all the gases. Okay. Is this balanced? It is. Nice. I think this is also kind of like an ice table, right? I think in this case, K is going to be equal to like the pressures. I think this is concentration of SO3. NO, right? All over. And if they had numbers in front of here, they would become exponents. And then this is SO2. And then this is NO2, yeah? Okay. And they all initially had a concentration of 0.8. Okay. So. if we were to set this up as ICE, I-C-E, these all are 0.8. I don't know, I think you just put like minus x on one side, and then plus x plus x on the other one. And so then this has to be 0.8 minus x, 0.8 minus x, 0.8 plus x, 0.8 plus x. Which then in here, if you plug that in, right? This is 0.8 plus x squared over 0.8 minus x squared. And that has to be equal to 3.21. So, right away, because everything's being squared, the square root both sides. So, square root of 3.21 is equal to 0.8 plus x over 0.8 minus x. Take calculator out. 1.79. Okay. Okay, so then I gotta do a little bit of algebra here, but I can just graph this. I'm just graph this. Save time with our algebra. So we're gonna say 0.8 plus x divided by 0.8 minus x. Okay, let's trace. Should get something nice. There's an intersection. So I can calculate intersect. Yes, you get x is equal to 0.2227. Here, I'll drop this graph in here. See it? Okay.
Back. Are we doing any hard questions? Oh no, chemistry again.
We had this one. This one was pretty hard. If you want to go do this one.
Oh,
This was from cheese pizza. It's in the homework help. It's the one we just did.
Alright, bet. Why are we doing chemistry then?
Because someone submitted chemistry.
I hate chemistry. What is this dude doing in the audience?
What a nerd. Tuma's making fun of you.
Yeah, no.
It's like
Bro wants harder question. Bro.
Yeah. Alright, 0.2227. Let's see. So it's gonna be 1.027, and then we're gonna have 0.8 minus that. Okay. No wait, 0.8 minus 0.227. Okay, cool. So the SO2 and the NO go down to 0.573. And the other ones go up to 1.027. I think. Let's see. See if ChatGPT agrees with me. Go do your parametric equations. Yes, 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 yes. Uh-huh. Uh-huh, uh-huh. Yep, okay. It agrees. Nice. We got it right. Thanks for the question, Jazzy. That's cool.
Yeah, put him under timeout. For 60 seconds, because he's supposed to these emojis as if he's some kind of...
What? You can put that emoji. I don't care.
He's just kidding. I'm just kidding. It's for 60 seconds. He's my friend, or else I wouldn't do that to anyone.
Okay. All right, that's fine.
I would. I can't be trusted.
Using mod powers, I see.
Abusing your mod powers. All right, let's mark this as done.
It's not abuse. It's more tyranny.
Tyranny.
I feel like abuse is like isolated to one person. You know, but,
Tyranny is just becoming like a tyrant over everyone.
Yeah, exactly.
Okay.
I'm not like isolating it to one person. I'm just equally dishing out.
It's like the South Park thing where he's like, I'm not racist. I hate all races equally.
Yeah, exactly.
All right, let's go spin another winner. Who are we gonna get?
Let's go gambling!
It's Fork. Or I think Fork. Your name was Feet. Is that what you said? Your name was Feet.
Cheat, bro.
Oh,
Okay. Oh, that's easy.
Do we know how to do this?
I know that's not easy.
I have a general idea. I looked at it. I haven't done any math on it, but
Okay.
I have a general idea, and my general idea makes me think that there's not a function f of x, but
Jeff says it's not that bad.
My name is Jeff.
Okay. 0 to 1 can be continuous such that 0 to 1 f of x dx is equal to 0, and 0 to 1 of x f of x is equal to 1. Additionally, assume for all x that are contained in 0 to 1 that f of x plus y plus f of x minus y is equal to 2fx f of y. Man. Okay.
yeah. See, I don't think that there's a function that exists for that. And yeah, I mean, you could prove it by contradiction, but like my first thought is right. Obviously, so f of x plus y plus f of x minus y equaling 2f of x times f of y.
Is like a sum? Is that a sum to product thing for like sine and cosine? We think.
Yeah. So that specific means that it either has to be of the form of a cosine or a hyperbolic cosine.
Wait.
Or it could be 0.
Because like the solutions to the equation is just like, wouldn't the solutions be f of x is equal to 0, and then f of x is equal to cosine of ax, and then f of x is equal to hyperbolic cosine of a of x. But like you can't use the solution f of x equal to 0 because the second integral condition wouldn't be like true or satisfied or whatever.
Yeah, for here, right?
No, the second one actually would. The first one wouldn't.
Oh yeah, the first whatever. Yeah. The x f of x dx wouldn't be if you use f of x equal to 0 as a solution.
Oh, actually, no. Wait, it would be.
How?
It would be the first one because 0 when you integrate it would get you. Oh wait, no, sorry. It's been a long day. Don't listen.
It's been a long weekend. It's okay. It's all right.
Yeah.
For this, I wanted this to like work out something like this. Because again, this is something I actually used when I was teaching my physics class on Thursday. If you add 2 signs here, right, you get 2 multiplier things. And then this would be nice, right? Because if A is x plus y and B is x minus y, then A plus B would give me, this would give me 2 sine of x. And then this would give me cosine of y. But I need this one to. So is there another one that's like sum the product, or are you guys saying it's something with hyperbolic?
It comes from another cosine, right? And then there's an analogous one for hyperbolic cosine as well.
All right, let me see. So I want hyperbolic.
I don't remember the exact derivation of it, but you use that a lot in PDE because that's a general, at least the left hand side is a general solution to a wave equation. So it's a pretty common.
Yes.
Yeah.
Y'all are right.
Hyperbolic.
There it is.
Yeah.
There it is. Ooh, okay, so this isn't too bad. So I was thinking about this in the right way. And again, this is so cool. This is from something completely random. I was teaching waves on Thursday, and I was using this identity a lot. I was like, oh, that's pretty fucking cool. I'm like, oh, wait, this actually looks very close. Oh, we just have to upgrade one more. We got to go one deeper to hyperbolic land to get this. Okay, so this is really cool.
And I mean, it makes sense that it happens with hyperbolics too, because hyperbolic trig is basically functionally almost the same definition. It's a relation between complex numbers. So depending on your input into cosine and cosh, you can swap
What's the
between
integral
them.
of hyperbolic cosine?
The integral of it?
Yeah.
The integral of it is hyperbolic sine.
Oh, wait, actually, wait. Isn't it negative
Yeah.
hyperbolic sine?
No, there's no negatives in it. The
yeah,
negatives
yeah.
in
Right.
sine and cosine come up because you get a e to the ix.
Yeah.
And an e to the negative ix. So when you integrate, those factors come out and brings out a negative, but there's no negative.
So wait,
there in the
so then the
hyperbolic.
answer just has to be.
I think it's just cosh.
Like, there's just one solution.
Isn't it just x?
So
Isn't it just
the
x cosh of
problem-
x?
No, so the problem that comes up is when we look at the conditions they gave us,
What for this?
it just doesn't work out. Yeah.
Oh, there are no function. Yeah, there's no function actually, because
yeah.
I mean, when if you integrate like if you apply the second integral constraint to the integral of cosine x, like of cosine ax, when you and like I tried doing integration by parts, I got like I got -1. I got something, but like I don't think it works for I don't think all of the three solutions work for some.
So what comes up is that, so if we first look at hyperbolic cosine, we integrate it and we get hyperbolic sine. And from 0 to 1, that is not
defined, or what?
what's it called? It's not 0, right? So if you think about the hyperbolic cosine, it basically looks like a parabola but just pushed up.
Yeah.
Oh, okay. So you'll never get 0
So
because
from
it's not
0 to
symmetric.
1, if we just think about if we think about the area of the curve under that, you're not going to get 0 from 0 to 1. So we know that it can't be hyperbolic cosine.
It's not 0 either.
Yeah, it can't be 0. And then if we look at cosine being the only other option, when we integrate it, and then you plug in your bounds, you'll get sine of a divided by a.
0.
And then so a would have to be equal to n pi.
N pi, yeah.
For that to work. So our cosine becomes cosine of n pi x, and then when you apply that to our second condition, you'll get a -1 to the n minus 1 divided by n squared pi squared. It's 0 when it ends even.
Yeah, you got that. Wait, I also got that. You got that by
2 over. Yeah, that comes from parts.
Yeah, I got that. So I got -2. If like
-2 over n squared pi squared, which can never be 1.
Yeah.
So that contradicts your original condition, and so we've basically shown that anything that could be of the form f of x plus y, f of x minus y, cannot ever meet those original conditions.
So you're saying that
because
like these are the only ones that would have been able to work for this condition, but then when you try to do them here, you don't get it.
Yeah, exactly.
Yeah, so the conditions don't line up.
Wouldn't it? Wait. First goes. Wouldn't it result in like a to be imaginary, like I root 2?
I think you could probably maybe come up with an imaginary. I haven't looked at the imaginary part of it, but
because
the problem with any sort of imaginary in that sense is that it maps
either way it wouldn't work.
The function maps from 0 to 1 to the real numbers. And so if you were to map that, you would have to take the real part anyway.
Yeah, exactly. I mean, even if you do the what do you call it, the imaginary part, it would still bring you back to hyperbolic cosine, the hyperbolic cosine of a of x, but still you can't do that either way. So
yeah, I mean, I can't think.
Femvox is not convinced. Femvox says I'm not convinced. Do we try throwing this one at chat?
Yeah, chat agreed with me when I threw it in.
Chat agreed that
Like,
there's no
that's my
solution
work.
either.
I threw it in the chat to pick my work, but
Wait,
Okay.
ChatGPT? Oh.
yeah, I have
Non-actual chat.
like a PDE calculator was trained on ChatGPT. Someone trained it to like learn and do PDEs and do math stuff, and so I use that a lot because it seems pretty accurate, and it seems to agree.
Okay. All right, let's move to the next one. So I have time. I'm running out of time here. So we got.
Let's go gambling!
Willie Manilli, wow. Congrats, Willie. What do you got for me? Find the Taylor series. Oh. Well, this is beautiful.
Oh.
We like this question. This is so fun. I feel like you can just like write this one out.
Can we get the ones where the people are actually here? No, you gotta wait your turn, buddy.
Who's asking that one?
You should have been spamming the votes for the past 3 hours, man. That's how you gotta do it.
That's how you gotta do it, dude. Okay. Find the radius of convergence. Yeah, okay. Taylor series is like it's like a Taylor expansion, I guess, right? And then they're saying okay. So f of a would be equal to sine of pi over 2, which is just equal to 1, right? So f prime of a would be equal to cosine of pi over 2, which would be equal to 0. F double prime of a is equal to negative sine, so this would be negative 1. And then f triple prime of a is again equal to 0. Okay, cool. So I think it's just going to keep oscillating like this, right? It's going to be 1, 0, minus 1, 0. And then the next one's going to be 1 again. And then... So that's going to be 1 plus... And then we would say, 0. X minus pi over 2 to the first. 1 factorial. Oh, I see. Okay, so only the even ones are going to survive. I guess that makes sense. So then it's going to be minus 1. This goes away. And then this is going to be 0, minus 1. And then this is going to be... X... Yeah. X minus pi over 2. To the second. Over 2 factorial. And then the next one's 0. Okay, and so forth and so forth. Alright, so this is going to be the sum from n equals 0 to infinity. And I think it's going to be negative 1 to the n, because I see that. And then it's going to be over 2n factorial, because I need only the even numbers here. What's up, Tuma? Yeah, you can come say hi. What's up, dude? Only the odd ones? I thought only the even ones survive. Is it the odd ones? Right? The first derivative of sine would be cosine. And then the cosine of pi over 2 would be 0. Yeah. Okay. So it's that. And then it's x minus pi over 2 to the 2n. Okay. All good, Lonesome.
Yeah.
No, it's good to check. I think this is the key thing. And so, again, for a Taylor series, it's equal to, it's like the nth derivative at a, x minus a to the n over n factorial. And so what I always do is I just calculate what like the first 4 derivatives are. I mean, this is f4 would then be equal to 1. And then I see what the pattern is. So, right, this is n equals 0. This is n equals 2, n equals 4. So only the even ones are surviving. So that's why I'm putting to the 2n. And then that's why I put to the 2n here. And then I think this is fine because every other term needs to flip between plus and minus 1. Okay, cool. So this is it. The radius of convergence. You gotta do the ratio test. Which I gotta remember what I do. I think I do n plus 1 factorial over n plus 1. Or sorry, I think it's n plus 1 over n. Yeah, okay. So we're gonna do -1 to the n plus 1, x minus pi over 2 to the 2n plus 2, because you have to put n plus 1 into the whole thing here. And then this is gonna be 2n plus 2 factorial. And then this is gonna be 2n factorial over -1 to the n, x minus pi over 2 to the 2n. Great. Okay, cool. And then we take the limit as n goes to limit as n goes to infinity. Okay. Bom bom. Well, here's the interesting thing, actually. This is alternating, right? And I feel like it's always decreasing. So is the interval convergence just like everything? Pizza, these are all JE main questions.
Yeah, they're all JE.
Oh yeah. You've been fortunate that I've been willing to do some of these JE questions just because they're not. This one wasn't awful because he can look them up.
Yeah, well, the first thing that I noticed is actually in the last one he submitted. No one else comes up with questions like with 2022, 2023, unless it's a graduating class in like a calculus course, or it's a 2022 JE.
Which question?
The other one in the queue he has.
They're all JE. The first one was the JE main 2020. Another one was the 2022. Yeah, they're all JE.
I think it just always converges. Always converges. Done. I think we honestly could have said that with the alternating series test anyways. It's alternating. 2n factorial will always beat to the 2n. So yeah, cool. Always converges. Nice.
Oh no.
Is it the main question?
Nathan, increase your mic, dude. I can't. Your mic's super soft, dog.
Oh, can I see the picture, the screenshot of the question?
Of which one? Of the Willie Minelli one?
Yeah, this one, yeah.
This one's easy, bro.
We did it. Here, I'll tag you. It's in here. The screenshot's in here.
I'll bet.
Was this your question?
No.
Do you want it? Okay. Let me see. I'm technically out of time, but I think I'll hang around and do a couple more. Let me see what we got.
Yeah.
Yeah. Tuma's like, come on, dog, help me out, bro.
You haven't answered any of mine yet.
Okay, let me go see.
Gotta wait your turn, boy.
Let me just see what we got. Okay.
But honestly, I feel like if they leave, you may as well not do it.
Well, that's true. But I mean, sometimes yes, sometimes not. Sometimes they leave and they come back.
Yeah.
Pick your question. Yeah. Let me see what cheese pizza's worth. This just looks like a nightmare. And then.
Oh my god.
What was the other one? Oh my god. Wait, what?
Oh no.
I think I've seen this question actually, though. I'm pretty sure I've seen this one. I've seen this one before.
Yeah, it's a JE one.
You can definitely, I can smell it, bro.
It's fun, man. Okay. Well, okay. Let me see. Then Zevstar is electric flux.
Oh, bro gave the solution.
Wait, what?
Oh no.
Zevstar is trying to speedrun getting bond coins, but I don't think understands how this works. You can't just submit a question with the answer. All All right, Tuma. I'll do yours just because.
Look at this easy question right here, bro. From straight
Actually,
from,
I already did this one. Let me give you a different one.
What?
straight from Weber sign.
I already did this one.
Straight
You already
from
did this
Weber
one?
sign.
Straight from
Yeah,
website. Okay.
here's,
All right. Give me the other one.
here, this one. Yeah.
Chop chop, bro. Chop chop. Well, not in the chat, bro. Put it in the queue.
It's okay. It's okay. It's alright. It's fine.
I figured it's easier for him.
Whatever.
Oh yeah, you did.
You did? Yeah, maybe. I don't know.
It would take longer.
Okay.
Bro, AFG.
All right. Let's see. The curve represents the following parametric equation. Indicate the orientation of the curve. Oh, okay. So this is the orientation. They're talking about like where it's going, right? So you always just gotta like you always just take this and like plug it into this, right? So this tells
I don't
me that
have a problem with that. Yeah, I just want to know like how do they figure out like the direction of it? Because
Oh,
you
okay,
can
yeah,
get
no.
two, like the same, you know.
I got you. All right. So t is equal to x over 2. So that means this is x over 2 minus 8, absolute valued, right? Which is the same thing as 1/2 x minus 8 x minus 16. Okay. So this is a function that is shifted horizontally to the right by 16, but then is stretched out by 1/2. So all of these are at 16, which is great. Oh, I guess they all kind of look the same. Absolute value should tell you right away, right, that this graph always has to be positive. So it can't be this one, right?
Wait,
It can't
did
be
you
this one.
factor out a 1/2?
Yeah, I factored a 1/2 out of this, just so I got it this way.
No, yeah.
Because
I didn't-
you really want to see things as it's like y of like a x minus h, and then it's like plus k. You always want to
Right.
factor out the stretch.
Okay, well, I didn't hear what you said after you
Okay,
solved it.
I said because y is an absolute value. Femvox, Femvox, you're right. I'll pull the other one up. Because y is absolute value, it can't be choice. It can't be these two choices because y is negative in those cases. Yeah.
Yeah.
Okay, so then let's look at like what t does. All right, so as t goes up, x needs to go up. All right, so this will tell you like you should always just write this out, right? T goes up, x goes up, and then let's see what happens to y, right? Well, as t goes up, y is also gonna go up, I guess, right? Yeah. Yeah. Well, y goes up and then down. Well, let me think. No, y goes down. Y goes down and then up. So which one of these has it going down and then up? It's gotta be this one.
I understood none of that.
No? Okay.
No.
All right. Just think about t. Just think about like, so what you want to do is you want to advance t in some way and then see what happens to x and to y, okay? And then see, do you see here on this graph, for instance, as x goes down, y goes down and then goes up? And then here, as x goes up, y goes down, y goes up. So I want to look here.
Who's tweaking out in the background?
It's probably his brother or something.
My nephew.
Nephew, okay. So here, all right, let's consider this, right? You want to think about like, okay, t is like a slider, right? That's the other thing. We could do this on Desmos if you want to see this here. Let's do it on Desmos. It's actually kind of cool. All right, so we said x was equal to 2, and then I think you have to do this. Is it capital T? No? Or no, sorry. Wait, how do we do parametric again? I think it's this. I think it's 2t. Yeah, there we go, comma. And then it was absolute value, right? Of t over 2 minus 8. There we go. Okay. And then, yeah, let's have t go from, -10 to like 40. Okay. Okay, so that maps out what, do you see this point? Like as I advance t, right? X is going up at first. X is still going up at the end. but y is going down. That's why it bounces, and then y goes up.
Oh, so up is to the right, and then up is
Well,
also up.
Yeah, so here on this graph, right? So
Yeah.
again, you could plug this into Desmos, just run the slider, and it'll tell you like which way it's going, or you can think of it kind of in your head of think about that slider T, right?
Yeah.
If I move that slider up, X will always go in the same way, right? Whichever way I move the slider, X goes the same way. So if I move X this way, so if I move T this way, X has to also go that way, yeah?
Right.
So I think right from the bat, right there, you can kind of say, okay, cool, I'm just done. Because this already tells you that X needs to be advancing to the right, but you should also check the Y as well.
Wait, but it's pointing to the left.
Yeah, this answer's wrong, right? Yeah, it's not this one.
Bro,
It's
it's
this
like
one.
it's pointing to the left. That means it's gonna go from the right to left.
Right. So if you look at the Y value here, right, and then consider, right, that X is always just going up, right? In this case, so as X goes up, think about this function, right? This would be 0 over -8, which would be +8. And then let's say X is going up to 4. Now it's 2 minus 8, which is -6, which is then 6. So do you see how, for instance, this would be like t is equal to 0. This is t is equal to 4. Or, well, yeah.
So you have to like put numbers in like from 0 to infinity.
Yeah, but you only need to really put 2. You just need to see which way it's going.
Oh, right. I know. But I'm saying like you wouldn't like put numbers the other way around, like from 0 to negative infinity.
Yeah, you could put negative numbers too. So for instance, I could have said like, okay, what happens at t is equal to, let's say, what happens at t equals 5, right? Okay, at t equals 5, x is equal to 10, okay? So here. And then, whatever, 5 minus 2 is 2.5, 2.5 minus 8 is minus 6.5, but, or sorry, yeah. Sorry. T is equal to 5, x is equal to 10. 10 over 2 is 5, 5 minus 8 is negative 3, absolute value of negative 3 is 3, right? So this point right here is 10 comma 3, and this is also like t is equal to 5. So then let me think of another t value. You could have gone further back. We could have said, okay, what happens at t is equal to 2? Well, t is equal to 2, x is equal to 4. Okay. So this right here is t is equal to 2.
This is such a weird concept.
It's so.
I mean,
what are you doing?
Yeah. I don't know.
No,
if it's
I
like,
get it. I get it. Like you have to find which direction it's going in, but like, I don't understand like.
Think of it like a race car. Like so, a parametric equation. You have the x and the y stuff telling you what like the overall like race path is, and then t is just telling you where you are along that path.
Formula 1 race.
Yeah. Like I don't know. Did you guys ever play with this
It's
fucking
just the
shit?
direction.
So the direction is as time goes up, as t advances,
Right.
you need to think about what happens to x, what happens to y. Yeah.
What happens to
Or-
X? If it's positive, then it's going right. If it's negative, it's going left.
Yes. Yeah. Exactly.
Oh, okay.
Fembox is right here. You actually don't even need to look at what the y does. You just need to look at the x. Let's say, for instance, here, instead of x being equal to 2t, let's say x was equal to like negative 2t. Okay.
Yeah.
Now, as t advances, x would go down, so it would probably look like this. Okay.
See, I think that maybe I didn't ask my question correctly.
Yeah.
That's why, because I wasn't getting the answer I wanted. But now I get
Well,
it.
I mean, you want to understand things, not just like get the answer you wanted. Yeah.
Yeah. No, not the answer. I mean, like the answer to my question.
Oh, okay.
Yeah.
Yeah. And then so here, you want to see the example of this one with the orientation?
The orientation.
Yeah. Well, this one, right? You're a little confused about the orientation, right?
Oh yeah, that one's interesting.
So again, I mean, all these graphs look basically the same, kind of, I guess, right? Well, what happens? Sorry.
They're going like two different directions.
Yeah. Well, also like this one's doing like, you see how the orientations are different there?
Oh yeah.
Okay. So you actually do need to like plug this in. But you know, oh, t minus 4 is equal to x. So this is the same thing as y is equal to, I think this is x plus 4
x.
over x. Okay, great. Yeah. So you know it has a horizontal asymptote. You know it has a vertical asymptote at 0, and then you know it must have a horizontal asymptote at 1. Because if you take the limit as x goes to infinity, this just becomes infinity plus 4 over infinity, which is just 1. Or you could also divide the top and bottom by the same. Or also you just notice, right? With rational functions, the highest power on the top equals the highest power on the bottom. You just look at the coefficients in front. Okay, so that tells you right away it's not these, right? It can't be this one. It can't be this one. So now you're already home free, which is great. Yeah. So now you gotta think about But now you gotta think about orientation. Okay, look, x is equal to t minus 4. So that means as t goes up, x goes up. So x needs to be going to the right as t goes up. This one has x going to the right as t goes up. But let's also make sure that y is doing the thing I need it to do, right? And so what I want to notice is, okay, if x is going up, what is happening to y? Because in this case, right, as x goes up, sorry, if the orientation was this way, that would mean that as x, that would mean as x goes down, y goes up. Yeah.
Yeah.
So usually these type of questions.
These are two separate. Ave, dude, what happened to your mic, bro, dude? What? Did you just like submit it in like to like a pool of water, dude? What? What did you just do to your mic?
Yeah. Yeah, that's at least.
Yeah.
Is it
Okay.
good now? Low.
Yeah, that was
Much better.
fine.
Much better.
Okay. Yeah. It was my AirPods. I don't know.
Okay.
Yeah,
Right.
but what I was saying is like usually with like these type of questions, yo, chill out, bro. Usually with these type of questions, you'll be like able to eliminate 2 options, just like with the absolute value. With the absolute value one, how it was like you could have said like it's positive or negative, so you could have eliminated 2 options based on like how the graph looks like. Then the last option you just have to determine the direction.
Right. I mean, he's just having issues with the direction, and all I'm saying here is, okay, fuck the y thing. Just look at x, and just say what happens as t goes up, and I'll be like, oh, cool, x goes up because it's positive, so that means it must be this, right?
Yeah.
T goes up, x goes to the right, which is up, which is positive, and then also from this, right? Once you're over on this side. Once x is positive, if x keeps going up, y needs to go down, which is what happens, right? This graph just goes down. Yeah. Does that make sense to him?
Oh yes. Like if you get a positive number for, like, kind of like as x goes to the right, it increases. Let me see.
You want to think about like just t. Just think about like what happens to t. Or what happens to x because of t. Look at t.
Get, like something positive.
T is positive and up, so x is gonna keep going up. Y is a little bit more complicated. Y is a little bit more complicated, right? Because technically for y, y goes down. Well, actually, y goes down the whole time, doesn't it? Yeah, actually it does. Actually, that's kind of cool.
Oh, y goes down. How'd you figure that one out?
Well, I'm just looking at the graph, but also from here. Let me think. Think about that. This is going up. As t goes up, you're always the problem is that like something happens at 4. At t equals 4. Right, oh, t equals 4 is the discontinuity that happens. Oh no, what happened to your mic again, dude?
Oh no.
Alright, whatever, fuck it.
Just my voice.
Yeah, just look at x. Just look at x. Just look at t and x. Is that cool?
Yeah.
Okay, good. Let's maybe end the stream before AFG's mic starts like graping me more or something, right?
Oh no.
Okay, does that help you too, Mo? Yeah.
I think
Oh,
we
very
should
much. Thank you.
ban him just for how his mic is sounding. right
Wow.
now. Purely for that reason. That should be like a capital offense.
Yeah, a capital offense, dude. My
Okay,
ears are
good.
hurting, dude. No, there it is again. Okay. Sorry about my mic. Okay. No, it's still bad. Okay. Okay, all good. I put your question in there. Yeah, now you're good. You're good now, dude.
Oh shit! Nice.
What's happening, dude? What's going on?
I don't know. It keeps doing something because like there's a video playing in my background, so it keeps changing the mic
Yeah,
to like
yeah,
that.
Stop gooning or something, dude.
Oh,
Focus on the math, dude.
I'm not tuning.
All right, let's close the stream out.
I'm not tuning.
I love, dude. You have a voice changer too, AFG. That's probably why. All right, thank you everyone for coming. Thank you everyone for coming to actual education.
Later. If.
Dude, what is that voice changer, dude? The voice changer is super loud.
Yeah, I don't know.
Okay, all right.
I don't know why.
Nice problem. Yes, thank you everyone for the questions today. Again, if you found us on all the fun things, go check out our website, www.actualofficehours.com. That's where you can find the link to our Discord. You can also find the streaming schedule. So these are all the times that we stream and all the times our friends stream. So there's a lot of cool streams happening this week. Zach's going to be on tomorrow morning. Go say hi to him. And then also you can go view us on Twitch and stuff. Yeah, okay. All right, let's go raid somebody on Twitch. Oh, Jesus.
What is he doing,
AFG.
bro?
AFG,
That was
dude.
not me.
That was
That was
totally you.
not me.
Stop, bro.
Nah, bro, shut up, bro. That was made up. That was not me.
All right, I'm glad you guys are having fun on a Sunday.
Baby voices engaged. Yes. Okay. Let's see.
Oh man.
Who are we gonna go say hi to on Twitch? Let's go say hi to somebody. I started following so many people at this other Twitch thing I went to. Skittish and Bus. That's a DJ person I know. Is anyone else doing like math or science today? No, dude. I have that one, not you, dude. Who is it?
Who has this focus?
Okay. All right, go say hi to Nerduino. Nerduino's great. We love Nerduino. Enjoy the rest of your Sunday. We'll see you Monday.
Yo, shut up, bro.
Because of the NASA Nordic Astrobiology Summer School. It was an incredible experience.